I'm Anil Kumar. Welcome to my series on solving linear equations. We'll take up examples in this particular video which are good for up to grade 9 students. We'll begin with very simple examples and all will be linear equations in our examples. Let us begin by saying that 5 more than a number is, let us say, 12. Then what is the number? This statement could be written as x plus 5 equals to 12. We get a linear equation. Now to solve this equation, what should you do? You can take away 5 from both the sides, and once you take away 5 from both the sides, you could say that x is equals to 5 take away 5 is 0, 12 take away 5 is 7. So you get the answer is 7. If I say twice a number is 12, that means I have 2x equals to 12. Now what is the number? In that case, I can divide by 2 now on both the sides, right? And solve the equation. So what we get here is x equals to 12 divided by 2, which is 6. Now once you solve, you can also check your equation. If I put 6 here, 2 times 6 is 12, left side is equals to right side, and we say that the linear equation has a solution which is x equals to 6. Now x equals to 6 is a solution means what? It makes left side equals to right side. Now you understand from these examples that equation will always have a equal to sign, correct? Many equations can be solved by inspection, just as we did them. We could have equation like 7 minus x is equals to 20, for example. In this case, how are you going to solve the equation? Well, we'll go with our strategy. We'll take away 7 first, right? So we take away 7 from both the sides. Once you do that, you get minus x is equals to 13, but it is minus x. You need to multiply both sides by minus, right? Then you get your solution as x equals to minus 13. So at times you may get answer like what we got, negative answers. You could also get answers in fractions. Let me take that example. Let us say half of a number is equals to 2/5. Now 2/5, how do we get the value of x? We multiply by 2 on both sides, right? So we just multiply by 2 on both sides to get rid of the fraction. That is the strategy. Once you do that, you get x equals to 2 times 2, 4 over 5. So you could even get answer in fraction just as we got here. Well, these are the very basic equations, and these equations help us to get a good foundation on solving linear equations. Let me now take few more and we'll combine now these operations together. So let us take an example like x minus 6 over 2 equals to 4. So I have combined that addition subtraction with division. How to solve such equations? Now to solve this equation, we should do, first step is get rid of fractions. We look for the number which when multiplied takes care of the denominator. In this case the number is 2. So we can multiply both sides by 2, right? If I multiply both sides by 2, what do I get? I get x minus 6 equals to 4 times 2, 8, and now I can add 6, correct? So if I add 6 on both sides, I get 6 plus 8 as 14, and I get my solution as x equals to 6 plus 8, which is 14. So that is how I can solve such equations. Well, there could be cases when we have fractions on both the sides. In that case, how do we solve the question? So that slowly we are getting into trickier part, right? So we'll have equation like 3n minus 2 over, let us say, 5 equals to 2n minus 1 over a different number, let's say 3. How to solve such an equation? Now it becomes difficult. Now in this case, what is the common factor? I should say multiple common, the least common multiple which we should multiply by so that both become linear equations without any fractions. The number is 15. So if I multiply both sides by 15, then what happens? Let us see that part. Now if I multiply by 15, 15 divided by 5 is 3, so I have to effectively multiply 3n minus 2 by 3, and the right side, which is 2n minus 1, by 5, correct? We sometimes call this strategy as cross multiply. So let me write down the strategy here, which is cross multiply. So in such cases, you can apply this strategy of cross multiplying. We cross multiplied by 2, got rid of this fraction. We cross multiplied this by 5, that one by 3. And now it is a question of expanding and solving. And that we have learned the property of distributive property, correct? So that is distributive property, right? So we can apply the distributive property to expand and simplify. 3 times 3 is 9n, minus 3 times 2 is 6, 5 times 2 is 10, right, 10n, minus 5. Now, okay, and 9n, okay. Now let's bring the terms together. Now we'll bring 10n here, 9n minus 10n equals to minus 5. And when you take 6 on the other side, it becomes plus 6. Now that gives us minus n equals to plus 1. So n is equals to minus 1. So that is how you could solve this particular equation, right? So it is kind of complicated, but I hope you now understand how to solve such an equation, right? So let me take now one more example. I mean, couple of more examples. But what we have learned here is how to take care of fractions, correct? Now we will take equations which involve bigger polynomials. We had a distributive property here, right? So now this time I'll take another example which is kind of more complicated. It could be like 3 times 4x minus 1 plus 2 times 5 minus 3x equals to 7x. So that is a very complicated linear equation. We'll now apply these strategies and solve this equation. Here we'll be able to teach you all the strategies learned so far. So first step should be apply distributive property, expand these terms, right? Distributive property means multiplying by the number outside the bracket by all the terms inside. 3 times 4 is 12, so we get 12x, minus 3 times 1, 3, plus 2 times 5 is 10, minus 6x equals to 7x. Combine the like terms. 12x minus 6x will give us 6x, minus 3 plus 10 gives us plus 7, and we have equals to 7x on the right side. Bring the x's together, right? So this way I could take away minus 6 from both the sides. If I do that, I get my straight answer, right? Minus 6x. Do you see that strategy? So what we get here is if you take away 6x from here, it gets added or taken away from the other side. So we get 7 equals to x. So x equals to 7 is the solution which we get for this particular question, correct? So likewise, you've seen how we can use the techniques learned to solve a linear equation, correct? Now we will take a few examples and let me call them as application examples. Many times we use applications where linear equations are involved. In geometry, for example, you know the sum of angles in a triangle is what? 180 degrees, correct? If I say that my triangle has the angles A plus B plus C and the ratio of, let's say ratio of angles ABC is 1:2:3. In that case, find the angles. Let us say this is my question. So the question is that the ratio of A is to B is to 3 is equals to, A is to B is to C is equals to 1:2:3. Find all the angles. Well, how am I going to do it? Let us say if one angle is A, then the other angle is 2 times A, that means 1:2, right? So 2A. And the third angle will be 3 times A, that means 3A. But we know A plus B plus C is equals to 180 degrees. Since the B angle is 2A, C angle is 3A, I could write this as A plus 2A plus 3A equals to 180 degrees. When I combine them together, what do I get? 6A equals to 180 degrees, correct? And A will be 180 degrees by 6. And that gives me the answer as equal to 30 degrees, correct? So if A is 30 degrees, B is, if A equals to 30 degrees, B equals to 2 times 30 degrees, correct? that is 60 degrees. And C will be 3 times 30 degrees. And that is 90 degrees. That means the triangle is a right triangle. So our answer in this case will be the angles are 30 degrees, 60 degrees, and 90 degrees. So likewise, we can solve many examples where we can form a linear equation and then solve it. The idea of this video was to teach you different methods and also to touch upon the applications where linear equations are involved. Distance time graph, whenever we are talking about, is a linear relation. So many distance time questions, then age questions are, or mixture problems. We have so many different types of questions. Ratios, rates, all these problems are solved using linear equations. Now I am providing you with the links where we will explore more about our applications, but I hope from here you get fairly good idea about techniques of solving linear equation, and I hope that helps. Thank you and all the best.